Welcome back to week 7. You're here with the Young Scientists Program, YSP of USC. My name is Samantha, and I normally teach 3rd grade at the 32nd Street Elementary Magnet School. Today, we're going to be talking about earthquakes and how to stay safe in the event that one occurs. Okay, so what is an earthquake? An earthquake is the shaking, rolling, or sudden shock of the Earth's surface. It's like the Earth's way of naturally relieving stress. The Earth is kind of like a puzzle. It has many different pieces, and these pieces are called plates. Millions of earthquakes happen across the world every year. The west coast of the United States, where we live, is actually very prone to earthquakes. This means that we are at high risk for earthquakes because we live where two plates meet, right here. So the Earth is a sphere. But it's not just one solid sphere. Its crust, or its outer layer, is broken up into many pieces that we saw before. These pieces are called tectonic plates, but we kind of see them like puzzle pieces. So these puzzle pieces, called plates, move by convection currents in the upper mantle of our Earth. So our Earth has many layers, so the top layer is called the crust, and the layer right below the crust is called the upper mantle. In the upper mantle, hot rock just below the surface rises. But when it cools, it gets heavy, so it starts to sink again. The theory of plate tectonics states that continents are drifting constantly from place to place, and they're breaking apart, they're colliding, or grinding against each other. This pressure that they put against each other often leads to earthquakes. A plate boundary is where two of these plates meet. You can have oceanic plates, like the ocean floor, and you can also have continental plates, like the dry earth. A convergent boundary, which is the first type of boundary, is where the plates collide into each other. Usually, whichever one is heavy is subducted. This means that it goes underneath, while the lighter one goes above. The next type of plate boundary is called a divergent plate boundary, and this is where the plates are going away from each other. Finally, the transform plate boundary, which the plates are sliding past each other. When the plates are stuck together, sometimes they break, they rupture. A rupture of a fault leads to energy transmission, or this means that energy is released. Usually the energy is released in waves. These are called seismic waves, but they look a lot like the waves or ripples of water. Basically, waves travel away from the epicenter, or away from the initial point of contact. So here are the two types of waves, called seismic waves. First are P waves. You can also think of them as primary waves, because they arrive first. This type of wave is a compression wave. The next type of wave is called an S wave. You can think of it as S for secondary because they arrive later. They move a little slower. This is the manner in which P waves move. Notice how the spaces are compressing together. You are probably more familiar with an S wave. An S wave moves a lot more like what we think a wave looks like. S waves are also sometimes called transverse waves. Notice how the Earth moves up and down as the wave travels. And now for our Scientist of the Week. This is Dr. Rufus Catchings, a USGS geophysicist who studies seismic activity. He is one of the first Black geophysicists and has paved the way for many new diverse scientists to come. Now it's your turn. For this activity, all you will need is a slinky, preferably a medium one. Now let's get started. First up is a P wave. To demonstrate the waves, have someone help you hold the other end of the slinky. Remember that the P wave is a compression wave. Notice how it doesn't move much to the sides, but that the slinky's coils bunch up together and bump the next one forward. As we go onto the S wave, notice that there's more of an up and down motion, or in this case, side to side. It almost looks like the letter S when it's moving. S waves move through the whole body of the object. Look carefully so you can pick out some of the differences between the two. Great job, scientist! Now let's figure out what to do in the event that an earthquake actually happens. Seismologists, or scientists that study earthquakes, use seismographs to measure how strong an earthquake is. But it's really difficult to predict an earthquake, which is why it's super important to know how to prepare for one. The best thing that you can do to prepare for one is to prepare an emergency kit. So on top of what you learn at school, like ducking under your desk or something strong, it's also important to prepare some type of kit for you and your family at home. This kit should include things like food, water, band-aids, first aid materials, gloves, a radio, extra batteries, blankets, etc. It's also good to put in some canned foods because they last a really long time and you don't need to cook them. Bye-bye. Thank you.